Hello everybody, Adam Lusek here, and today I will be going over my approach to this phenomenal challenge set out by Andrej Karpathy. To provide a little bit of context as to what this is, Andrej recently released this phenomenal video on tokenization and everything you really need to know about tokens, tokenizers, their pitfalls, their benefits, a little bit of things about, compression algorithms, and all sorts of fun stuff about tokens that you need to know in this lovely 2-hour and 13-minute video. If you've never seen a video by Andrej, highly recommend checking him out. He's one of the best in the business when it comes to educating around these language model theories and ideas. But after he posted this video, he tweeted this out on February 22nd. Fun LLM challenge that I'm thinking about. Take my 2-hour, 13-minute tokenizer video and translate the video into a format of a book chapter or a blog post on tokenization. Something like Whisper the video, and that's in reference to Whisper-1, the audio-to-text model, chop up into segments of aligned images and text, prompt engineer an LLM to translate piece by piece, and then export as a page with links citing original parts of the video. More generally, workflow like this could be applied to any input video and auto-generate a companion guide for various tutorials in a more readable, skimmable, and searchable format. And so when I read this tweet, I thought that's something that I could totally do as like a weekend project and try and figure out. Especially as someone who's a bit more of a novice programmer, this is a phenomenal challenge to throw my head at, as it requires a lot of different sort of working pieces in between here. So let's go into a little bit of what the output I got was and how I got there. So after a long weekend of throwing my head at this challenge, this is the final automatically generated output that we got. So as you can see here, it's in a nice Markdown format with things like chapter titles, and it's effectively summarizing the parts of the videos, attaching relevant images from that time in the video, and then also including hyperlinks to the part of the video. You can link directly to these chapters, and it pretty much goes through and does this for the entire 2 hours and 13 minutes. There's definitely some limitations here, which we'll go into when we start talking about how this is actually set up, but as you can see, for the most part, and we'll get to something like this as to why it linked to 1 hour and 13 minutes into the video later. But for the most part, it's able to pretty much effectively take this video, super long, chop it up into more readable, more searchable parts, more linkable parts as well, with what it believes to be the relevant pictures and the relevant part in the video. So it goes through all of the 2 hours and 13 minutes and puts together this phenomenal companion guide, summarizing relatively accurately a lot of what's being talked about and just organizing it into a lot of really nice little sections here that you can go through. So as you can see, this one's quite long, since for 2 hours and 13 minutes, a lot of topics are being talked about and a lot of things are happening on the screen. But I'm very pleased to see that this output, especially since it was all automatically generated, looks as good as it does here. So super happy with a lot of this, and I'll have a link directly to this actual output in the description if you want to check it out. But let's go into my approach and how I actually managed to get this output happening. So hopping over to the Jupyter notebook that was, everything that I saw for pretty much the entire weekend. Let me go over just my general flow before I reveal what my nice and messy code looks like. So what I ended up doing is a little bit like this. I would download the video and the audio file from the video, chunk the audio so that I could insert it into Whisper-1, generate a transcript with timestamps, which is something that Whisper-1 can do, chunk the transcript, generate Markdown formats with placeholders on that, and then I actually embed the timestamped transcriptions into more of a vector database, and then I similarity search for parts of the video that are relevant to the generated Markdown chunk, and then at that I grab either the hyperlink or frame, replace the placeholders with the relevant media, and then export it all into this Markdown file so that it looks like this. So to go over the code a little bit, this is what's actually happening. I have a timekeeping function here just so that during my main script, I can keep time and show how long each part actually took. And then I go over here, I use PyTube to download the audio and the video files just by creating a PyTube object where I then grab the highest resolution stream, which if you don't want to do anything fancy with combining the video and the audio file is just going to be a 720p file. Save that as the video file. Similar for the audio stream, just grabbing the audio, the first one, and downloading as an MP4. Additionally, saving the title here. It gets a little bit more complicated when we check the actual file size and chunk the audio. For some reason, in the actual documentation of OpenAI's Whisper-1 file, I couldn't get their proposed solution of splitting the audio file to work. So instead, I stumbled through actually recreating and re-encoding the actual file, which I ran into a strange phenomenon here, and I'm no expert really with working with audio files, so this is definitely a limitation of my expertise. But when I took this audio file, which ended up being about 48 megabytes when I downloaded it, and split it into two, the two files themselves turned out to be 33 megabytes. So no clue how that happened, but my clunky solution was instead of splitting it into two, I split it into four. So I tried to put a chunk size of 24 megabytes into my function here that I wrote, but instead I just ended up going with 12 so as to not run into that 25 megabyte limit that Whisper-1 can take. But I have a flag variable for, a little bit of interesting handling as to whether or not the audio file actually needs to be chunked, so that if I put in a file that's not over 25 megabytes, it can get to the right path in the different functions coming up. But pretty much just checks the size, divides it by some megabytes, by some megabyte calculations, and then re-encodes basically into different parts the new audio files. So I'm no expert, as I said, of working with audio files like this, so I'm sure this is very suboptimal, but in the end it was able to give me files that were under 25 megabytes, and that's all I needed really, because I can combine some data later. The actual transcription from Whisper-1 is what's happening here. So a lot of this is a way of actually just checking and then organizing the audio files so that I do everything in order. But the main part of what happens here is it'll iterate over either the individual audio file if it's not being split, or over in order the chunks that are split, and then shoves it into Whisper-1. So Whisper-1 has this phenomenal format called verbose, and you can do it by timestamp granularity segment, and it'll actually output a great file, which we'll jump to now to talk about. So if you have the verbose JSON argument set, and then also the timestamp granularities as segment, it'll output a segment of text here, and then the start and the end in seconds here. It then also gives you a lot of other stuff like the temperature, log prob, tokens, and things like that. But most of what's relevant for what we're doing is actually just this text with the start and the end time. But heading back here, it'll do that over all of the audio files that exist if necessary, and then pretty much goes through and cleans it up a little bit. So I have it all put together, all of the audio files, and if it's more than one, I have a little bit of handling for when it actually gets to the end of a file to update the accurate start and end time of each segment. I also take out some of the unnecessary information that I won't be using in this program, and then it combines it all into one nice combined data JSON file. That combined file then looks like this. So it just has every single segment and all of the relevant information that I want. I keep the ID, I keep the start time, I keep the end time, and I keep the text string. So this is the entirety of that 2 hour and 13-minute video from Andrej, all put into a wonderful single file of I think it's something around 9,000 lines. That again, it does count everything like this, but with handling of the start and end time and the ID number for every single one of these. So great continuity here. And then as we see, if we reach the bottom, the end time, here we go, is about 8,008 seconds, which if you do the calculations, turns out to be roughly 2 hours and 13 minutes. So phenomenal output there, nice and cleaned, ready for us to work with. So with that, I also wanted to grab the full transcript so that we can chunk it up for the language model. So all I did here is iterate over all of the entries, grab the text part of the dictionary, and add it to one nice long string. Then jumping down to our main script all the way at the end here, I actually decided and ended up using the semantic chunker from LangChain to chunk together the text. So semantic chunking is a phenomenal, I feel, process created by Greg Comrot, and I'll link to this in the description as well, which pretty much splits the text based on semantic similarity. So it uses a little bit of OpenAI's embedding model to then look at the similarity of groups of sentences with the next, and then once it changes enough, and you can do that by percentile or by standard deviation or by interquartile, it will then chunk it at that point. So I decided to use this as it would be a little bit more accurate than just doing something like, split by character, split by token size, especially since there's a lot of different topics being talked about in the videos like this. So I thought this might more accurately chunk where topics start and where topics end. So it ended up chunking pretty great. And then what I do is I just iterate over all of the chunks. And if they aren't very long, I just add them to the beginning of the next chunk. So I felt that this was a decent approach, as since it's chunked by sort of similarity, these are including more so full thoughts or full ideas. And so it wouldn't be too bad to just chunk them a little bit together. I also wanted them to at least have a 2000 character length so that I can actually get some good output when I run it through the language model. So not 100% perfect, but gave me some great chunks of the actual text, all in nice large formats so that I can then shove it right into GPT-4 Turbo. So then we get to the language model part. So let's go over the prompt that I actually input to deal with these chunks of text that we generate from the transcript. So this is the prompt that I ended up using. Below is a script from a video that I am making into a companion guide blog post first. You are a helpful assistant made to assist in the creation I'm doing. This is a continuation of a guide, so include chapters, key summaries, and incorporate visual aids and direct links to relevant parts of the video. However, do not include any conclusion or overarching title. For visual aids, specific frames from the video will be identified where images can be inserted to enhance understandings. For direct links, portions of the text should be hyperlinked to their corresponding times in the video. To indicate that a sentence should be hyperlinked, insert the raw text of the transcript next to the word with the indicator hyperlink corresponding transcription text, period. To indicate a picture regarding the text, insert the indicator picture corresponding transcript text. It is crucial to use the raw text from the transcript that will be used, as the additional tools that will be inserting the hyperlinks and pictures need this to know where in the video to look. So from this first initial paragraph, a few things here. As you can see, definitely a lot to be optimized about this. My grammar and syntax isn't even that great here, but a lot of the times it's able to pick out the necessary things here. You can also see that I included some interesting things. I said this is a continuation of a guide. And the reason that I did the continuation of the guide is so that it doesn't think that it's creating like a full start to end as we iterate over the individual chunks, since it's not all going to be input at the same time. It's going to be combined. And a few other things here, I have it place placeholders for hyperlinks and placeholders for pictures. And I ask it to input a chunk of the raw text that's actually being used to create the other sort of summarization beforehand. And we'll get into how I deal with these later, but as you might start to be thinking, I'm going to be using some sort of search to find the relevant part and the relevant time. To go on a little bit with this prompt, I have in this blog post, in addition to the paragraphs, create titles or headings that encapsulate main points and ideas. Format your response in Markdown, ensuring distinction and clean styling between titles and paragraphs. Be sure to include the image placeholders and hyperlinks with enough distinguishable text without any quotations, as the placeholders will be fed into a semantic search algorithm. This structured approach will be applied to the entire transcript. The example below only shows one style, but use multiple styles, including different headings, bullet points, and other Markdown elements when needed. I then give an example input. So I had this generated just from ChatGPT and their UI, where it has pretty simple, introduction, a little bit of that, and then what I'm looking for in the placeholder with things like, picture, and then the raw text that was used to create this. I give the example and then a few example outputs, and then I have end examples here, and then here's the transcript and transcript. The rest of this is pretty general lang chain stuff. The output parser of just a string, LLM being GPT-4 Turbo, and then using chat prompt template to create this with a runnable pass-through into a nice LangChain chain so that I can invoke it with each individual part. And that's exactly what's going on in this function here with generate markdown. It's pretty much taking all of those merged documents and the chunks that we had and iterating through them, running them through this prompt piece by piece, and then joining them together with a couple line breaks, outputting into this LLM outline.txt. That LLM outline.txt file then looks a little bit something like this. So it'll have the accurate markdown formatting and then different placeholders. So it'll decide, seemingly almost random, honestly, whether it wants to insert a picture or a hyperlink to the part of the video. It does the summarization and creates the title pretty accurately, or the different section titles, and then includes a little bit of the raw text needed for where in the transcription this is actually coming from. So it goes through, creates all of this, combines it into one nice text file, and then all we need to do is handle these placeholders. And so to deal with these placeholders, I took a pretty interesting approach. I actually decided that I was going to use some similarity search, as briefly mentioned, to find the right part of the video to link to, or the right part of the video to grab a picture from, using the placeholders and the raw text from the actual generated, from where the part of the script is generated. So I'm using FAISS, which is the Facebook AI Similarity Search Library, to actually embed the combined data JSON. So if we go back to the combined data JSON, I'm taking each individual entry here and then splitting them up into individual points and then embedding them into vector space with FAISS. I use a bit of a JSON loader from LangChain and then the embeddings from OpenAI's embeddings to create this quick vector database of all of those entries. Using the database then, and to actually process the placeholders, we have all of these lovely functions. So pretty much what it is pathing a little bit to the relevant things that we're going to need. I then create a retriever from the vector database, and this argument here is actually very important. I'm using a K of 1 argument, which is one of its limitations, definitely. But what that basically means is that when we're doing that semantic search, it's only going to return the top most relevant search result from that. So this is one of the limitations for sure, as when things are a little bit more vague, it can sometimes not find the exact point that I'm looking for, but I would say it's about, 90-95% accurate at this current point. And so pretty much how it's doing a lot of this stuff is it's opening the text file and then it's finding these placeholders. So if it starts with a picture, it's going to grab the description and then shove this description into this retrieve time function, which is where we are doing that similarity search with the retriever. I then load this as a JSON because it's going to be in this format right here. So it'll grab the most relevant entry here. And then I'm finding the start, the end time, and then I'm just taking the middle of it, the average of it, and then rounding that. And so that will be the final time that I'll use to both find the actual picture frame and then hyperlink to the video. So as we can see here then, it then does exactly that using the time. If it's a hyperlink, it'll format it to a hour, minute, second so that it can be nice here, and then create the hyperlink with just this quick hyperlink function right here. If it's an image, it takes a little bit more effort. I take the second that it thinks the relevant frame is at, and then I'm using CV2 here. Does a little bit of FPS calculation to find the exact frame given the second, but pretty much just does that, grabs the relevant frame, and then returns the path so that I can output this Markdown friendly format here to embed an image. All of those are then replaced with their relevant things here, and then a final Markdown file is output right here. The main script then is just putting everything all nicely together in order. So to get the final order, I download the video here, grab the title, split the audio if necessary, process that audio with Whisper-1, combine it all into a nice transcript, and then also the combined JSON. I pull the full transcript, chunk it as we went over with the semantic chunking. Also, I embed all of the combined data into this vector database, and then I generate the outline with GPT-4, and that puts in all the placeholders and the markdown, and then I convert all of the placeholders with their relevant either pictures or hyperlinks. We can see here that this is about how long it took for everything here to actually get done when I input the actual tokenizer video here into it, which took about 1,316.19 seconds. And so that comes out to about 21 minutes and 56 seconds. A little bit of the other notes, the actual cost of putting this full video through this was about $1.91. $1.10 comes from GPT-4 Turbo, where I had 56,000 context tokens and then 17,000 generated tokens. Whisper-1 was a little under $1 at 80 cents for the 8,000-ish seconds that it transcribed. And then a little bit negligible, but still necessary, the embedding model cost about 2 cents for 172,000 tokens here. But at the end of all that, we have this phenomenal clean output here with relevant pictures, hyperlinks to the video.
Now, in my previous...
Nice. And as we can see, there's still some of those limitations coming up. So right here, when he's talking about CL100K, it's jumping actually to the middle of the video, with it, which is out of sequence to some of these things here. But he talks about it at the beginning and then also at the end. So that's where that actual similarity search is failing. But for the most part, it's able to take a lot of this stuff, grab some fun pictures from it, and then hyperlink to the relevant parts of the video. So super happy with the actual output that I was able to get and the automatic output. And as we know, this is all done. Just input the URL and this markdown file is pasted out. So phenomenal stuff here. Definitely some limitations, but super happy with this sort of initial pass through. I list out some of the limitations, and as I put here, my to-do list of other things that I thought. As we just mentioned, vector search can sometimes be inaccurate, point towards some of the wrong parts of the video, out of order with this exact method. This could be solved with, more accurate chunking. Of course, Andrej says chop up into segments of aligned images and text, but instead my approach was just taking the full text and searching over it. So if you had a more powerful, vector database or a more powerful searching algorithm, or just more context to find the exact part of that, that would definitely help with getting exactly the relevant part that you want. There's a bit of an inconsistency also with the number of pictures and hyperlinks across the board, as these placeholders are just automatically put in from the language model. You can't really 100% say, at least with my prompt, I didn't 100% say that I want n number of hyperlinks or n number of pictures. So sometimes we'll get more hyperlinks than not. Sometimes we'll get more pictures than not. Like this right here, it went on a tear of just pictures. And then sometimes it'll just put hyperlinks, but a little bit of inconsistency there that could be addressed, likely in the prompt. Also, unable to put the entire script in at once. I tried this, it would not work. But this then, of course, comes with all of the downsides of sequentially inputting chunks and then combining it together. What would be better if I could put the entire script in is that it would have the context when generating the markdown file of everything, so it wouldn't have to necessarily forget what it did prior and then generate more markdown that's then put together. So all the downsides that come with the sequential processing of this are definitely visible, since it'll sometimes, and I tried to address this with the semantic chunking, sometimes start or think that it's starting more overarching topics when it's actually continuations, but could be done with better chunking and maybe a better approach to this. Also, some of the other things that I said is could be prettier. This is certainly usable, and I actually think that this is pretty decent in comparison to what he actually put out here. So this was sort of his sort of approach, doing it manually himself, of what it looked like. So not 100% accurate on that, but for an automatic generation, not too bad. Then, of course, I have a bit of limitation with things like working with audio files, working with vector databases, and other just general programming stuff. So if I spent a little bit more time on it, it would probably get a bit of a better output, but super happy with the way this turned out. So all of this stuff will be linked down in the description to all of Andrej's materials, and then also my GitHub page where you can check out and download all of the code that I wrote here as well, or check it out on your own time. But thank you for watching.